All right, 4.7, strategies to subtract decimals. So I can use strategies to subtract decimals. I'm going to show you 2 more strategies in addition to the strategies I've already showed you of decimal grids and sort of the traditional way of subtracting. So just other things to try and then see if it fits for you or not. One thing I want to point out is why we might estimate. Keep meaning to say it, I'm forgetting. But if you are wanting to double check that you got a reasonable answer, that you didn't accidentally line things up wrong or forget to borrow or something, if you estimate and you see, okay, my answer should be close to 10, but then I get like 25.32 as an answer, like, those two are not very close. I should double check both my estimating and what strategy I used. Maybe I didn't line it up. Maybe I forgot to put the 0. So that's one way why we estimate, is to see, like, did I make a mistake in my answer or is it reasonable? Just wanted to point that out. All right. Problem for this one is, how can you determine how much more precipitation Olympia, Washington receives than Salem, Oregon? So these are states out on the west coast of the United States. So Olympia is a city in the state of Washington. Salem is a city in the state of Oregon. So comparing how much precipitation, so snow and rain and other things like that. 23 and 89 hundredths inches versus 19 and 29 inches, hundredths inches. So what equation could we use to find how much more precipitation? We're thinking about P. Well, how much more means what operation? Subtraction. We're comparing, so we can subtract those two to find the difference, to find how much more it gets. So what strategies could I use? Again, we already know 2 of them, grids or traditional. We could also decompose numbers to find partial differences. So go ahead, write that in your notes. We can decompose numbers to find partial differences. Just like partial sums, but this time partial differences. It's a little bit different because we're actually only decomposing the second number, not both of them. All right, I'll show you an example. So I leave the first number alone. I decompose the second number into expanded form, 10, 9, 2/10, 9 hundredths. Okay. And then I subtract each piece. So 23 and 89 hundredths minus 10 gives me 13 and 89 hundredths. 13 and 89 hundredths minus 9 gives me 4, because I took the 13 and I subtracted 9 to give me 4. Notice I haven't subtracted any decimals, so my decimal has not changed. But then now my whole number is going to stay the same, but I'm subtracting 2/10. 8/10 minus 2/10 is 6/10. And then 9 hundredths minus 9 hundredths, I don't have any hundredths left. So I just get 4 and 60 hundredths. Now this can get real weird, like with borrowing and different things. So we do have to be real careful. I think this is good to understand what's happening. I don't think it's quite as practical of a strategy to use for all your problems. But I do want to show you so you can sort of see, like, oh, I can just subtract each part at a time if I wanted to. So then 4 and 6/10 or 4 and 60 hundredths is my answer. So I could also think of adding a missing number. So I could say this plus something equals my answer. That's the difference, is what's missing. That's another way to think about it. So if I think about it that way, I can count on, just like you might say, 8 plus what equals 12? Well, I could start at 8 and go 9, 10, 11, 12, so then it's 4. Same idea, just with decimals. I can count on, I can see how much more do I need to add on using a number line. Okay, so go ahead, add that to your number line. Ooh, I think I missed a couple things on your notes. One way to decompose numbers is to use expanded form And then when you subtract each part, make sure to subtract from the right place. You can add those on your notes or just keep moving on. All right, another strategy, again, is to count on using a number line. So, another strategy to count on is to use a number line. So, how I would do that? I would start at 19 and 29 hundredths. Okay, so I'm trying to get to 23 and 89 hundredths. So, different ways. But I could say, okay, count up 1, that's 20 and 29. 21 and 29. 22, 23. So these were my 4 wholes. Now I'm at 23 and 29. And I could say, okay, now I need to go from 29 to 89 because I do have my whole number done. So I just can look at my decimals. So 29, 39, 49, 59, 69, 79, 89. I counted up 60 more. So I did 1, 2, 3, 4, 5, 6 little jumps of tenths. So I added on 60, or not tenths, hundredths more to get me to my final answer. Again, less of a practical solution because it requires a lot of like counting in your head, which it's easy to get mixed up. But it is good to realize that that is a strategy. So if somebody showed it to you, be like, oh yeah, that's one way I'm counting up to see how much I need to get there. Okay? And if I put those together, I get my same answer as before. So, that's how they showed it. They did the 6 tenths first and then the 4 wholes. Either way will get you to the right answer of 4.6 or 4.60. So, I can either subtract using partial differences. I could count on to find the missing parts. Either way, it receives 4 6/10 inches more precipitation. Okay? So now you have 2 more strategies to use for subtraction. We're going to do some practicing, and I'm fine with you using any of the strategies that you would like. I'll try and show you some of those again, just because I know they can be tricky. So go ahead, do 8 and 57 hundredths minus 2 and 4 tenths in any strategy you would like, and then we'll go over it. All right. So they're showing decomposing and doing partial differences. So if I do 8 and 57 hundredths minus 2, well, that's subtracting from the whole place, so I'd have 6 and 57 hundredths. And then I can take 6 and 57 hundredths, subtract 4 tenths. So if I start at 5 tenths, subtract 4 tenths, I'll have 1 tenth left. So I have 6 and 57, and 1 tenth, and so my 7 hundredths. So then I know my answer is 6 and 17 hundredths. Okay, so I just did it part by part instead of all at once. You might have just written them vertically, subtracted like normal, and that is fine. All right. 7 and 73 hundredths minus 5 and 1/10. Go ahead and figure it out. All right, hopefully you got it. Notice how they took 5 and 1/10, subtracted the 5, then the 1/10. So they decomposed it and subtracted it one part at a time. So 7 minus 5 is going to be 2. I will still have the 73 hundredths. And then if I subtract 1/10 instead of 7 tenths, I'll have 6 tenths left. So I get 63. So my answer is 2 and 63 hundredths. Okay. So 6 and 31 hundredths minus 9 tenths. Go ahead and use this strategy to figure it out. All right, hopefully you got it. So I'll try and show you how we can count on. Again, it's a little tricky on here. Oh, they gave me a blank space this time. Great. So I'm starting at 9 tenths. Okay, and then I could think, okay, I need to get up to 6 and 31 hundredths. So I know if I add on like 5 wholes, I'd have 1.9, 2.9, 3.9, 4.9, 5.9. So that was 5 wholes. If I do 1/10, then I'm going to get to 6. And then I just need to do 31 hundredths more. So this 10th plus that is 41. So then I'd get 5 and 41 hundredths. You're like, I have no idea what you're talking about. That makes no sense. That's okay. Just remember we were figuring out this plus something got me to 6 and 31 hundredths. If you just did 6 and 31 minus 0.9, put my 0, 1, borrow, 13 minus 9 is 4. Okay, that's fine too. But do understand that the counting on will work. It's just maybe not as efficient or easy for you, and that's fine. Okay? I'm going to leave it there since we've practiced last lesson and this lesson. I think even the lesson before at this point was subtracting decimals. But if you're still confused, let me know. Good luck.